In this video, I'm going to share with you the first principles way of learning and teaching. So that is the way I try to teach. So I'm going to explain the level of depth uh, that I try to teach at. So let's start with an example. Um, so when I was preparing for CAT back in 2006-7, long time back, 20 years back now. I'm not very old, by the way. So um, So they used to give us a lot of shortcuts, tricks to use. For example, let's look at one of the uh, shortcuts they used to give us. So for example, let's say if you have to calculate the square of 47, how do you calculate? So the shortcut we were taught was, okay, so just look at 47 is just 3 away from 50, right? So it's 50 minus 3. So 47 is essentially just 3 away from 50. Now you know the square of 50. It's 2500. That's easy to calculate. Now, since this is just 3 away from 50, subtract 3 from this. So you get 2200. So I mean, subtract 3 from 25. You get 2200. And then just add the square of the distance, which is 3 square. So what you get is 2209. This is the square of 47. Similarly, you can find the square of any number which is close to 50. So let's say even if you have to calculate the square of 41. So you'll just look at, okay, this is 9 away, right? It's 50 minus 9. So it's 9 away from 50. So what you'll do is 25 minus 9. So 16. And then you make it 1600. Plus you add the square of 9. So what you get is 1681. So this is the square of 41. Okay, so this was the shortcut that was taught to us back in 2006-7, that how to calculate the squares of number which are close to 50. Okay. So yeah, many of us used to just start applying the shortcut, start getting the answer, start solving questions faster. But somehow I was not very happy. I would sit on my desk and think, why does this shortcut even work? From where have they arrived at this shortcut? So I kept thinking about it, and of course, they gave us a variety of shortcuts and tricks, and I would think the same about all of those shortcuts and tricks. But I'm just taking an example here. So I would think, but why is this working? How does it make sense that, okay, it's 3 away from 50, so you subtract 3 from 2500? I why does this even work, and does it work consistently? And if it works consistently, then why is it working? From where is it coming? So then I realized basically it is simply an application of the basic formula of a minus b squared, where a just happens to be 50. Okay, so if a is 50, so now let's open it. So what is this equal to? A minus b squared. So it's a squared plus b squared minus 2 into a into b, right? So then it becomes, this is just 2500 minus 100b. So I'm just bringing this, and then plus b square, which is, if you take 100 common here, it becomes 25 minus b plus b square. Oh, so this is where the shortcut is coming from. So, right, so that 3 is just b here, and that 9 is just b here. So eventually I figured out that all the shortcuts, tricks that they were teaching were just coming out of basic math formulas. If I understand the basic math formulas and how that is being um, used to arrive at shortcuts, I can also create my own custom shortcuts. And then I will not need to necessarily remember those specific shortcuts all the time. I can just know the formula and how the shortcuts are arrived at, and I can just use the formula in an efficient way in the exam. So this is the difference between a trick, which is the same as, let's say, shortcut, versus application of a concept. So if you are using this whole technique trick without understanding where this is coming from, then you're just using a trick. But if you understand where this is coming from, then you know the basic formula, basic concept, right? Just a minus b squared. That is the concept from which that particular shortcut is arrived. And perhaps different other shortcuts can also be derived from the same formula. So then if you understand the basic math concept from which that shortcut is coming, then the shortcut just happens to be an application of a concept for you. You may still use a shortcut. I may also still use a shortcut. But I know where this is coming from, and I can derive it, and I can derive other shortcuts also. So I'm just clear about it. Okay, so that is the difference between trick shortcuts and application of concepts. So, of course, there are different companies in the test prep space which operate at different levels. So some operate at the trick level primarily. They're giving a lot of tricks and shortcuts. Some try to also make you understand the concepts deeply and then say, okay, if you apply this concept, then this is kind of a technique we can arrive at. So you can also use this technique directly, but they're also explaining you the concept. Now, is there something deeper than understanding concepts also? I think yes, it is to not accept anything on face value, that you keep questioning. For example, I asked you what is a minus b square. Then we said, okay, it's a square plus b square minus 2ab. But then I may also ask you this question, why is that the case? Why is a minus b square is equal to this? Why not something else? If you know the answer, then your understanding is deeper. But if you don't know the answer, you just remember this, oh, this is a basic math formula we have been taught. Why this exists? No, this is just basic math. It exists because it exists. Then you have accepted a lot of things on face value. You don't really understand where they are coming from. So this is just coming from the basic understanding of the square. Square just means multiplication of the same thing twice, right? So it's a minus b into a minus b. Now, what is a minus b into a minus b? Right? We use this, that is it's equal to first a into a minus b, then minus b into this a minus b. Right? So if you do this, a square minus ab minus ba plus b square. So you get a square minus 2ab plus b square. Right? Now again, here also, why does this open as this? Why do you do a minus b and then first you multiply a with this entire bracket, then minus b with the entire bracket? Why do you do it this way? Again, if you know, or if the answer is very intuitive, then it's fine. But if you have no idea, you have just remembered it as some property. Okay, this is how it was taught to us in school, that it is a distributive property or what, different kinds of properties. But no, but then again, you may ask, why does it even have this property, right? For example, you are being told that, okay, this formula follows this property, but why does this formula follow this property? You may ask that question, right? So again, why does this happen? It simply, you can understand is, if it were, let's say, not a minus b, something else, let's say a simple thing, you can call it c. Then how will you do it? C into a minus b. You will do it as AC minus BC. Perhaps this is easier to see. Now you can see that if this is what we do, then if C were A minus B, we will do this. So you can understand this whole expression, the way it is being opened, it's just coming from this basic understanding, right? And again, why you can even ask this question, why is A minus B into C is equal to this? And you can take examples to see what could be alternatives. Why does it make sense? Okay, can it be some other alternative which is possible? And you will realize that no, this is the only thing that makes sense. So this is the way sort of I have studied. So not accepting things. So for example, if you give me a formula saying that let's say F is equal to AB R square divided by F cube, something random formula, then I'll try to understand why do we have R square, not R cube, and F cube, not F square or F4. Right? Why do we have A and B here? What is, so we are essentially saying as A and B go up, F goes up. But why is it the case in real life? So I'll not just accept this formula because, okay, you're saying me it's written in a textbook. So yeah, I'll just go on and apply. So I may apply the formula, but then I've not understood if I have not asked these questions. Understanding the formula means you can really understand why each part is there. What is it doing there? And why is it there in a specific way? For example, why is it R squared? And why is it F cubed? And why is F in the denominator and R in the numerator? So first principles learning and teaching is just about understanding things at a lot of depth, in which no question is a silly question. Every question is worthwhile, and it's about asking a lot of questions. Actually, first principles teaching, if I say that's what I do, then it's actually about asking from the student a lot of questions so that over a period of time the student starts asking a lot of questions. And I think only if you ask questions and pursue them, that's the only way to build depth. That's the only way to build clarity. That's what I'm trying to deliver in my sessions. I hope some of this kind of explains uh, what I do and how I've studied. Again, if you have any questions, please feel free to ask.